Vad bra. Tack så mycket. Ja, göteborgskan försvann. Det var inte så länge jag var där. But I will switch to English, and that's partly because my family is here, and partly because most of the work that I'm going to talk about is the work that I've been doing for the last 10 years, and that has much more been in a English-speaking context. So some of the terminology is actually still a bit of a struggle in Swedish, but I'm working on that one. I would also like to say thank you to the previous presenters, because you, for example, just now when we heard about the agriculture development in Sweden, you seem to have data that we are struggling to find in our Newton universe of today in sub-Saharan Africa and Asia. We can't find yield or income levels to explain processes of development, and particularly maybe to make those transformations in agriculture that we need to obtain sustainability, food security, poverty alleviation, and climate-smart solutions. So we have a big piece of work ahead, and I'm very happy to have colleagues that will be able to help me on this very important thing. The other thing was that this is a very topical topic, agriculture water, because yesterday was the World Water Day, maybe some of you knew, and they just presented the decade of water for sustainable development. So I see that there is a lot of scope here for this piece of work from this university to contribute on an international and global arena about sustainability and water management for food security. We talk about water, and it's often like weather: too much, too little, not good, usually. And in Sweden here, just the last 2 days, I just picked yesterday, of course, because of the Water Day. There was a bit on the water insecurity, more on the domestic side. And the previous one was about the Cape Town thing, which I think most of you have heard about, the town running out of water, and they were given a month to actually have water. And it's a real crisis in certain parts of the world. I have lived in the UK for a while. The last 15 years was doing research in different places. And there we have a lot of problems with water. And I want just to highlight, this is from 2012, but 1 month we had a super crisis of drought. And 30 days later, the York city was completely flooded, like you see on the picture there. And this is actually a normal. These extremes of water, and in Yorkshire, which is an agricultural, like Skåne, this is a very big problem, and I'll come back to that later. But here today, it's interesting also because in Sweden it's becoming a much hotter topic. And this is just in February, I think. And some colleagues were talking about the lack of fodder and the price of fodder, and this is due to the rainfall variability last year that is now affecting, so all the what do you call that? Slakterier are overbooked because the farmers can't actually maintain their cattle to a good and healthy standard. So water is very important also here in Sweden, actually. And I'll talk about something about that global framework about sustainable development that we are working within and contributing to. The change, all these various changes that are happening globally and locally that are important for agriculture water management. I will take some examples of opportunities that I've been working on in big research collaborations over the last couple of years, and some specific actions that are really worrying me, and I hope that our research will contribute to understand better. And the good thing, and I'll give you the key messages because you might get too hungry for lunch, is that there is some consensus on the challenges, yeah? And the other thing is there are opportunities. And those are the 2 key points, and I'll repeat them before you leave. Right, so this is, we had an exotic picture of South Africa and chasing spiders. I didn't chase spiders, I was looking for water. But this was in Niger when I just finished at SLU, and I worked in a project in Niger. And it's a very good example because what you see in the front is a farmer's field, ready, it's time for planting, even though it looks a bit dry. And then you see all the water below the field, and obviously not very usable for the particular plants we're planting. And what I wanted to say, that this is essentially what I've been trying to work on for the last 25 years. Getting the water to the right place at the right time in the right amount. And sometimes in a very small plot, and sometimes in a more landscape perspective, and sometimes we also do a couple of estimates at the global level. First of all, I wanted to specify which water we are talking about, and this is from a book that we wrote with a couple of colleagues also from this university, Johan Rockström, Malin Falkenmark, obviously not from here, but also well renowned in this field. The water that we're concerned about is the light green box. Can I point this one? Is there a pointer? Den. There. The grazing land and the cropland and the irrigation. Those are the three boxes that I'm worried about or concerned about or looking at. And they contain about 20% of the total rainfall on all the land area in the world. So the other 80% or so is sustaining our ecosystems in different ways. But these are the type of water that we can use for productive purposes and manage if we have information and knowledge. The other thing that is important is that although irrigation often gets a lot of attention, most of our food and the land area is the crop and grazing land. So in that sense, we need to focus on both systems and the whole continuum between the rain-fed to irrigated. And the third thing here, you saw the headlines about the women and water, is that there is very little water at the end of the day that goes to domestic and industrial, but it gets a lot of attention, a lot of investment, and a lot of decision worries. Right. So the consensus, this is from the World Economic Forum. They make risk reports every year. And for me, this is interesting because this is the private sector and the guys with the money. And they make this ranking of what is high risk, high impact problems. And I am happy to say, because it makes my life easier, is that food security and food crisis, water crisis, environmental, climate change related natural disasters, which are very much water related, those are listed very high in these risk reports. So that's good news for me. And the second thing that is very good is that they agreed on a development agenda for the world. And even Sweden, or not just even, but of course Sweden was part of this and driving some specific aspects of this very intensely, is that we have an Agenda 2030 that goes down to all the policy also in Sweden. From my perspective, we are working on the zero hunger goal for poverty and for hunger and food security, the clean water one, the number 6, of course, climate change, and a little bit on energy. So it's a very interdisciplinary field of work, even though I'm now part of the Institutionen för Mark och Miljö. It needs some interdisciplinary work here to solve some of these problems. Right. So the challenge is there's no straightforward relations between water, soils, and climate. So in the Agenda 2030, this is a huge problem, but I think that we will see that every time we try to solve a problem, we come into this systems approach need, even when we talk about fairly simple things like irrigation equipment or soil structure to manage the water. And this is a flooded field, not so far from my hometown. with a wasted crop standing there still in December, which is a very depressing sight, but very difficult problem, and probably one we have to address much more in our coming days of research. So we don't have any linear relations. I was interested to see the Kuznets curve. We talk about tipping points, nonlinear relations, and I would see that Kuznets curve talking about where is the technology changes coming in and how does that make the shifts in income or productivity, but we'll take that one day. And we tried again to map some of these critical environmental or natural resource tipping points some years back. And this is for water, where we know that these areas are important food baskets for the world. In the Midwest of the US, Australia, lots of wheat coming there. Here, the Nile, very critical for millions of peoples. And of course, Asia and China. And there we have an over-abstraction of groundwater in many of these regions that are hampering production and productivity. So we're reaching some sort of production limit with the current knowledge we have. And we also did similarly for land soil degradation, very roughly, that we have some critical land challenges, and they're reaching a point where we're really hampering the production and the productivity of the farming systems in these areas. And these are exporting areas, many of them, or very densely populated areas. So if these production systems are not working, it's actually affecting our food, our ICA price shelf, prices on the shelves, and not the least, the fodder supply for many products we have here in Sweden. So water goes beyond the borders. It's not enough managing and worry about water just in Sweden. We have to worry in other countries because it's our food security. More water also is needed because people are getting more money. Unfortunately, we tend to eat more water-demanding diets, even when the absolute population is increasing. And it's more fodder that we need to produce, more vegetables, more fruit, and we need it every day of the year. Not just apples in August, September, but actually every month of the year. And this demands water and a steady supply of water, and therefore there is also a need to make sure that we manage our water for that. Finally, on the challenges side, the climate change is a big blue dark cloud on the horizon, and we're not super clear on what actions and where we're going to put our effort to address all what might come in terms of climate change to our production systems and water. And this is just a summary showing that some people say that we will have, and maybe already have, temperature is the red ones. So it's a decrease of yields, in this case maize, for Brazil, China, France, and a few other countries. And it tells you about the approximate decrease. So they say like about minus 10% already. The precipitation is still not so clear, because precipitation predictions are very unclear or uncertain. But the temperature alone is decreasing our production capacity again. And this is a fundamental challenge. And what do we do in terms of water management to address these coming challenges? And of course, we have this issue about, you talked about the yield increases. Yeah, the yield increases more than the population. In some cases, it seems like we have some yield stagnation. And that means that the yield increases are not increasing. They are stagnating. And that doesn't go very well with the population increase. So even though we have enough food maybe today for feeding the global, and we have some distribution challenges, which is not fine, but what it is, the fact that our production system can't increase and keep pace with the population growth and the population demand is a very big challenge. And from a water perspective, it probably means that we need to intensify more and use more water. This has happened in the past. So in Asia, for example, you see here you have the yield increase on the x-axis here, and then the area increase on the y-axis. And then you have a production metric based on those two. And then you have them for different years. So it starts 61 with the FAO data. This is 70, 80, so up to 2007. We should do new ones now. So what it says is that essentially you have had a yield increase in Asia, but it has not necessarily expanded very much in terms of area or production. So there's been a real intensification. Yeah? You intensify on the existing cropland or grazing land. Whereas in Africa, it's the opposite. We have a very marginal from 100, it's an index from the starting value, to about 160 in terms of yield, where you had from 100 to 240 in Asia, right? And then you have an expansion of the area. And that's, I think that, I can only speculate, of course, but I think a lot of this intensification is about using water better and really leveraging the fertilizer and the better seeds that has been part of the green revolution. If you didn't have the water to make another season available, you wouldn't have had that intensification happening. That irrigation use or water management use has not happened yet in sub-Saharan Africa. But it is maybe happening as we talk. Now, where am I on time? Too late. Okay, so the opportunity very quickly. I really want to end the day here on a happy note, because I think there is a lot of hope and possibilities. And this is from irrigation, smallholder farming irrigation trial, testing new technologies of irrigation for dry season irrigation in Ghana, which they typically don't do as part of the culture. So I was saying this is a complex system. All the other researchers today had said the same thing about their topic. But my system is, as I said, the Newton system, in the Newton universe. That's where I work. And we still lack a lot of data in that universe as well. And I want to say that it goes from the soil to the field to the landscape, essentially. And even there, we struggle to transfer our processes from the plot or the soil to the landscape. And it doesn't correlate and it doesn't aggregate very well. Then we add the crop, which complicates things a little bit. And then we have the technologies that is supposedly providing us with the solutions to manage all this. And then there's water flowing in this. And then there is people. And that is a complication of bigger magnitude than any other of the other parts. But here I'm trying to say that, you know, if we don't include our people in our studies, we will probably not get very far. So they are very important, even though I'm very much in the biophysical part of the world, the universe. So some of the questions here are like, how does the processes, are we using the right process descriptions, and are we doing it empirically to the models that we're using at the different time, space, scales? And how can these interactions become more productive? What do we do? Which technologies? And how do we work better with nature on restore and enhance natural processes to manage our water in our soil and for our crops? And how do we make it sustainable and viable? And preferably, it should be economically viable as well. Example here in Sweden, and so I've just come back after being away for quite some time, so there's a lot of things that I taking in. But it's very clear, like everywhere else, that the temperatures are increasing, which you often can mean that you need to manage your water in a different way. There's some patterns on the rainfall and the shift in seasonality and the fact that we have less cold winters as well, but there is extreme uncertainty. And we have a postdoc, Ewan, with us, who's exploring these climate data and testing them for agriculture production perspectives, which is a challenge, but very necessary work. And here I just cut an example that overall it seems like they're estimating a more drier here. And it's maybe particularly interesting here in the eastern part of Sweden, that was your interest, that it seems to be a very challenging area for different reasons, including climate variability. So we need better precision in water management to climate-proof our Swedish production system. And there is a need to do that because actually Sweden has expressed an ambition to be better on food security, which means internal production to supply the food in the country. And they had a policy on that 2016, 2017 on Swedish matsäkerhet. And it dedicated half a page to agriculture water management, actually, which was also very nice for us in research. But the drainage of the fields in Sweden, which is about 50% of the crop area, the increased irrigation demand, and continuous work to improve structure. And we need to explore much more what those solutions might be. Because at the end of the day, we want to produce and we want to transform, as we talked before, from this manual, very difficult production system to something that is a little bit more productive and beneficial, still hard work because you're lifting the water, and to something like here, which is climate smart and with clean energy. And this is a transformation because we hope that with the technology today, we can make that transformation or that technology jump. And we think that small-scale irrigation is an overlooked area, and this is part of work I've been doing for more than 10 years in a big consortium, and I don't want to say how much money, but what it shows is that smallholder irrigation is about 100 times bigger than official irrigation areas in some countries, and which means that a lot of people depend on this for their livelihoods. We did some scaling of opportunities. As part of that, it was for Bill and Melinda Gates Foundation, and so we have quite a lot of people that could benefit from different water infrastructure investments and agriculture water management, different technologies that we tested. But of course, it comes with some uncertainty, again, because we don't have data on very much. And there are some sustainability aspects that need further development. And I need to move into the flowers, they told me. Okay. The solar pumps is one such that we think could be a real winner because it is climate smart, it has a low carbon footprint, and it does provide the opportunities to farmers. There's only one big problem at the moment, but we hope that the cost curve will come down because it's already had. It's very expensive for smallholder farmers. In sub-Saharan Africa at least. And we need to develop some more understanding on the implications for environmental factors around this. And we have I would say, almost nothing understanding of increased water outtake and water quality. We can make some models, but what farmers actually do on the field is very worrying in terms of pesticide and leakage. The other example that we have done a lot of work on is the small reservoirs infrastructure. And although people are not, it has a little bit of a mixed value in Sweden, talking about farm dams and farm ponds. This is something that we're actually discussed very much in the UK because of the climate variability coming up and how to design and how to make best investment in small farm dams. And Here, I think the interesting thing is that this investment was done in the 80s and the 90s, and is coming to the end of their lives. So it's actually not generating as much benefits and production to the agriculture as it used to. And the question that our research is about is how do we help support better investment to rehabilitate or regenerate this huge infrastructure that covers a part of West Africa. It's about 1,500 small reservoirs. I think we have in a database, but that might not be complete. We took some of these watersheds and modeled them, of course. We couldn't help ourselves. We had some land use from 55. This one is from Burkina Faso, and it shows that the transformation of the landscape. But we cannot say, we're not trying to say whether it's good or bad, but it's just something that has happened and is happening very quickly. But here in 1955, 80% of this watershed of 1,000 square kilometers was savanna, yeah? And there was only natural waterways. And in 2010, 80% was rain-fed agriculture, and they had built a total storage volume from 2% of the annual rainfall. The annual rainfall is 712. That creates the opportunity for this dry season irrigation I'm on about on 1% of the area. And when we model these different systems, the basically natural and the one with a very much more managed agriculture water, we see very small changes in partitioning to runoff groundwater recharge. Yeah? So essentially, it doesn't happen very much on an annual water budget. So we cannot always say that irrigation development is harmful for our downstream flows. And this is very important because this is very often an argument for not investing in infrastructure that could really benefit people and their livelihoods. Finally, okay, so we need some action. When I came to the corridor, there was this sign. This man with a rod. And then a few weeks later, there was this news in the BBC that scientists, they did a study on the UK water companies and said officially none of them used the rods to find water. But when they were asked more deeply, it turned out there were quite a few of them who actually did among the technicians. Now, I would not like to leave things to random, hazardly kind of things, but I would like to say that in my world and what I do is to develop open access knowledge and capacity. And here, the capacity, because we do really need capacity. And when I see like your presentation earlier this morning and knowing the lack of data that we're struggling with, is like how can we merge or how can we utilize these methodologies also in our size of our plot landscape work and benefit from the existing data that we already have, actually. So better management needs more than one part. We need knowledge, capacity in information, because we need to move away from these, I don't know what to call it. Anyway, let's go on. So the action needed. One thing that is very, and I will finish in 2 minutes, and one thing that is really intriguing me is this lack of soil physical parameters in soil databases. And I was just discussing it with some colleagues the other day, and we did some testing of different pedotransfer functions from one database. And what we find was that the same input, very different output. Here you see the different distribution of the results, and I only took a few of them. And it's scarily, because these pedotransfer functions are used to describe water flows in our soils for very many different assessments in global and local water modeling. Another thing that is very concerning is this climate scenario data development for agriculture purposes, because it governs so much of our rain-fed and irrigated systems opportunities. We need to understand how we scale this and how we use them for the future. And we find that actually the downscaled scenarios as they are now seem to be very insufficient in describing very important features like dry spells and high rainfall events, both in Sweden and in this case in Burkina Faso. Okay, I'm finished now. I wanted to say I had a couple of messages that you remember for lunch. There is consensus on the challenges. I hope you're convinced too about that. There are many, and they are big, and many are related to water in agriculture. And the opportunities are there to do the things differently. And I think that here, the need for new knowledge and capacity with systems perspective and contextual, technical and other solutions will be key. Thank you to new and former colleagues, students and collaborations, various funders, and the audience today. Thank you.